Greetings everyone. I am Yukti Verma and I am from Raipur, Chhattisgarh. Currently, I am pursuing my BTech in Government Engineering College Bilaspur, Chhattisgarh. And here is my dream team members, Niraj Jaiswal and Sonal Verma. We all are from GEC Bilaspur. And in second year of our academics, we got the opportunity to get trained from Fine Tuning Academy Noida in Verilog and Hardware Digital Design implementation on the FPGA. And currently in third year, we get trained in VSDL from Fine Tuning Academy and a real-time project UART Transceiver using VSDL assigned to us by its own R&D company, Aegis Technology. Apart from it, we did many more projects in Fine Tuning Academy in our second and third year journey, such as a clock divider, LED pattern generator, sign calculator, and its implementation on 7-segment display, a car speed monitor, push button, a sequence detector, and the traffic light controller, and many more. All the BSTL projects are accomplished under the guidance of the senior engineer, Dipanshu Chauhan sir. And this project, UART Transceiver using VSTL, is get explained in today's presentation. So, first of all, I would express my gratitude to the Fine Tuning Academy and Aegis Technology to provide us hands-on training on VSTL, Verilog, and hardware digital design, and for the guidance to complete this project. So, as the continuation of this presentation, first of all, we will discuss about the content that will be covered in this presentation. We will start the presentation from the brief introduction of our UART, its basic three principles, and its frame format. Then we will move towards the VSDL coding part of UART transmitter and its visualization using the Nexus A7 FPGA. UART, Universal Asynchronous Receiver Transmitter. It is an serial communication protocol that establishes communication between two connected devices, such as a microcontroller and its peripheral. UART basically follows three principles. The first one is asynchronous data transfer. Means the two devices that are connected together cannot share the same clock frequency. The second one principle is full duplex operation. UART basically supports the bidirectional communication, means at the same time, the transmission and reception is simultaneously occur in the single device. The third principle is flexible baud rate. UART supports the wide range of baud rates, and through the flexibility of baud rates, devices can communicate with each other with the different clock speeds. Now we will see the UART to communication frame format. As we know, our actual data is only 8-bit long, but at the time of transmission, our UART transmitter module frames our data by adding the start bit, stop bit, and the parity bit. The logic 0 represents the start bit, which acts at the front of our data, and logic 1 represents the stop bit, which acts at the end of our data. So usually the UART frame is 11-bit long, but not every time the parity bit is necessary. So the parity bit may or may not be present in our UART frame form. So that's all about the theoretical analysis of UART, its principle, and its frame format. Now, we will see the physical significance of UART transceiver. So, what's the transceiver? Transceiver is nothing but a single module or single device which can handle both the transmission and the reception of the data simultaneously. Means at the same time, a single device can transmit and receive the data. Here we have an FPGA board, which is a Nexus A7 FPGA. Through this FPGA, we can easily visualize our UART transceiver project. Here are a total of 16 input pins, which are switches. Through these switches, we can give the input what data we need to be transmitted serially. After the FPGA is programmed, firstly we give input to it. And after giving the input, there is a need of serial communication. So there is total of 5 checks of PMOD port. PMOD port having multiple input-output pins, which is the serial communication pin, along with the VCC and ground pins. So what we need a jumper cable, and one end of the jumper cable is connected to any of the pin of the PMOD port. Through this end of jumper cable, our input data is transmitted serially, and through the another end of the jumper cable, we receive our serial data again from the PMOD port. Now the connection is done. Whenever the FPGA is programmed, firstly we will give the input. Our input drives the switches, and after the switches, our input goes from this PMOD port, and from the one end of the jumper cable, our data is transmitted serially, and the another end, the data is received serially. But after the serially reception, we can show our data in the parallel form in the LEDs of the FPGA, or we can, for the better visualization, we can also seen in the 7-segment displays. So this single FPGA means this single device also perform the transmission and also perform the reception. Therefore, we can also say it's as a transceiver. This FPGA works on the serial communication, which operates on the UART protocol. Therefore, we can visualize our UART transceiver using VSDL project on this single FPGA module. Now, for the VSDL coding part, I would like to call Sonal.
Now we are focusing on the VSDL coding for your transceiver. So there are basically 4 modules to design this UART transceiver. The first module is transmitter module. In this module, we will give the 8-bit data as input, and then transmitter at start and stop bit respectively 0 and 1. Then it transmits serially this data to the receiver. Now the second module is receiver module. In this module, a receiver detects only start and stop bit and accepting only the 8-bit data, then deserialize this data to know about the data which to be transmitted by the transmitter. Now the third module is baud rate generator. It's generate clock signal for the desired baud rate. Now the fourth module is top level integration. In this module, we combining all these 3 modules in a single code. Now we can see the UART transceiver top view. In this top view, we have 2 modules, UART transmitter and UART receiver. Now I saw the VSDL code for UART transceiver. This is my UART transceiver code. In this code, I will call all these 3 components, and after that, I put map all these codes, UART transceiver, UART receiver, and baud rate generator. Now it's my UART transmitter code, and I am using generic clock generator to set the baud rate. And it's my UART receiver code, and it's my generic clock generator to set the baud rate, both the receiver and transmitter. Now we are discussing the implementation on FPGA of this code. For implementation of this code on FPGA, we need to follow the process of input-output port mapping, implementation design, synthesize, and generate bit file. After that, we program the FPGA. During the process of input-output port mapping, we map switch as input and LEDs as output. One more connection we have to do it for the serial communication. So we use PMOD port, which have several serial communication pin along with ground and VCC. So we can through the jumper wire, we connect one of the serial pin as transmission line and the second serial communication pin as reception line. So we can easily visualize our output on LEDs. For the proper visualization of these outputs, we can also use 7-segment display, that means SSD, on FPGA. So we need to one more port to write, so which is a 7-segment display driver at the receiver side. So we can easily visualize this code on FPGA. So now I am called Niraj to explain further.
Hello everyone. In this image, we will see this UART implementation on LED. So firstly, we will give the input and which is transmitted and we get receive signal on LED. In this image, we will see this UART implementation on SSD. Now FPGA is programmed and we will hide the reset and we will give the input and then reset is low, and we will give the start transmission and reception. Here is the data exchange between two device through UART protocol. Now, first FPGA is transmitted data and second FPGA is received data, and transmission of device 1 is connected to receiver line of device 2, and receiver line of device 1 is connected to transmission line of device 2, and ground are connected together. In this image, we will see this UART implementation on SSD. Now, clearly see this output, and so all about our project and UART transceiver. So thank you, everyone.
Now we will show you the demo of our UART transceiver project using the FPGA. Here it is an Nexus A7 FPGA board in which there are a total of 16 input switches. Through these switches, we can give the input with what data we need to be transmitted. After we providing input to these switches, the data is need to be transmitted serially. So for this, there are a total of 5 jacks of PMOD ports. This 1, 2, 3, 4, and 5 are provided. This jacks having the multiple serial communication pins along with the ground and VCC pins. By taking a jumper cable, we can connect one end of the jumper cable from any of the pin of this PMOD board. Now, whenever we give input to this at the switches, our data is transmitted through this end of the jumper cable. Now, the another end of the jumper cable is connected to the another pin of the PMOD board. So, from the another end, we can receive our data serially. Now, whenever we program our FPGA, first of all, we will give input here. Then our data is transmitted serially. Then from the another end, we get our received data serially. And the received data is shows on the 7-segment display. We can also show at the output as the LEDs, but for the better visualization, we can see it in the SSD. Now it's time to program our FPGA. Here our FPGA is programmed, and in the initialization, we got 0, 0, 0, 0, 0, 0, 0, 0 at the SSD because we cannot give any input to it. Now, first of all, we will hide the reset pin. After it, we provide the parallel data 8-bit data inputs. Here I am providing 4 consecutive ones and 4 consecutive zeros to it. Now, again, I am lowering the reset pin. Now I'm starting the transmission and the reception. So when I'm starting the transmission and the reception pin, we got our transmitted data, which is transmitted serially by using this jumper cable, and received this data by using the another end of the jumper cable serially. And the output is shown as the 7-segment display. Now, if I'm changing the input pins, like I'm zeros, our received output also changes. So in this single FPGA module works the both as a transmitter and the receiver. Therefore, we will call it as the transceiver. And this transceiver, based on the serial communication through the serial communication pins of PMOD, and this serial communication based on the UART protocol. So here's the complete demo of our project, UART communication transceiver using the VHDL coding. Thank you so much, everyone.